All right. Hello, everyone. Thanks for coming to the blog writing workshop. We are thrilled to have Lauren Lipuma here today, who is with the CIRES comms team. And I'm just going to read her little bio here. She is currently the scientific communications editor and the acting communications director with CIRES comms. She has a background in engineering, but has worked in science communication for the past 10 years as a news writer, editor, photographer, graphic designer, and video producer. At CIRES, she writes and edits news stories about CIRES projects, produces videos and infographics, and helps manage the communications team's projects. So we are thrilled to introduce her and have her lead us in how to write engaging blogs. Awesome. Thank you.
Awesome. Thank you, guys. Thanks for having me. Welcome. I hope this is fun and informative for you guys. Oh, there we go. I was going to do an about me, but Allison already gave me a great intro. Yeah, so I'm on the CIRES communications team. I've been with CIRES for about a year, but in my work, I've known about CIRES for a long time. Love all the amazing work that goes on here. Really happy to have joined last year. So yes, as Allison mentioned, my background is engineering. I started off with an engineering degree, worked in an infectious disease lab for about 5 years, and then switched over to doing science communication. And I've worked for the American Geophysical Union and some other scientific and medical societies, doing news writing, covering new research. So a lot of writing, a lot of multimedia as well, doing some video work, design, photography. Photography is also a hobby of mine, so I really am passionate about it. So I'm gonna just give you guys some tips that I've distilled over my years of communications and also training other scientists how to communicate. So I've kind of boiled everything down into 8 tips here that I'll go through. So first is consider your audience, use plain language, make it personal, tell a story, and try to incorporate elements of news writing and multimedia, make it meaningful, and then the last one I'm not going to tell you to the end, just to build some suspense. All right, so first is consider your audience. Whatever you are writing, whatever producing, whatever you're doing, you always need to think about who is your audience, who's going to be reading this. Think about who they are. Are they adults? Are they kids? Is there a specific demographic group you're intentionally targeting, like, you know, future scientists, students, policymakers, the media, whoever they may be? Just think about who they are and where they're coming from. Also, if you're talking to the general public or anyone who's not in academia, just think about when was the last time they took a science class or even a class in your field or in the field that you're communicating about. Like, most adults in the United States haven't taken a science class since high school, maybe college. And doesn't mean that they can't understand what you're talking about. It just means that you have to provide a little extra context and dial down the jargon to make sure that they can understand what you're talking about. So just think about that. Think about what's important to them. What is their perspective? Is there something they're particularly concerned about? You know, is it, does a certain community deal with issues like air quality, say, or, you know, natural disasters of some sort? You know, what do they care about that's related to the science that you do? Think about all of those things, and that will really help you, you know, craft a message that will engage them and help them remember it and take it home. And I think the biggest thing I can stress is just to use plain language. Try to be as clear and concise and conversational as possible. Write. It may be a little bit difficult to do at first, but try to write as if you are speaking. Something I like to do is when I write something and then I read it out loud, if it sounds odd to speak those words, then go back and rewrite. Sometimes things sound different written on the page than they say spoken out loud. So try to be as conversational as possible, as clear, try to avoid as much jargon as possible. And sometimes you do have to introduce some jargon or technical terms. That's okay. Just make sure you explain them and try not to introduce too many at once. Then people are just going to be caught up every time they come across that word or that acronym, trying to remember what it means. And then they may lose sight of the bigger picture of the message. So just try to keep it to a minimum. And again, provide that context. People, you know, outside of your field, even outside of academia, may not understand the importance or the impact of what you're talking about. So you have to provide that context. Think about what research has already been done in this area. You know, what do we already know? And then what is the new piece that you're bringing into this? And I try to say, keep it to a high school reading level or ninth grade reading level. This is really hard to do. I try to do this in my own writing, and it's really, really hard when you're talking about science, but try to lower the reading level as much as you can. Try to get it to a high school reading level because, like I said, most adults haven't taken a science class since high school, but also most adults read at a high school level. Doesn't mean that you can't do something that's a little bit higher, but you don't want to go so high that it becomes like an academic paper, and then it's really just hard for lay people to understand. I found this scientific, see if you can see this. Hold on, let me move this over. I found this Scientific American article from about a year ago that shows even lawyers don't understand the legal jargon that other lawyers use. So this is not a problem that is just specific to science. It's everywhere. So, you know, sometimes even other scientists can't understand the jargon that you're using. So just think about that and try to, you know, use as much plain language as you possibly can. Okay. Try to use stories, examples, metaphors into your writing, and try to incorporate social math too. That's just where you compare numbers to something that's more easy to understand or digest if the number is really large or really small. This is just an example of what I did. This is an infographic I came up with a couple years ago at my previous position. Just kind of comparing, I was writing a story about how much Antarctic whales eat, and the amounts are so substantial that it's really hard to understand like what 500,000 kilograms is. So I just compared it to the size or the weight of the space shuttle. So you can see blue whales eat a ton. They eat about 7 space shuttles worth of food in a year. The minke whales are smaller. They only eat about 1. So just kind of think about if there are any kind of comparisons you can make with your data, with your numbers that might make it easier for folks to understand. And make it personal. Add in a human element. It is totally okay to add in your personality. Show your excitement that really engages people. Show your personality. Talk about maybe your successes, even your failures and the challenges, because people really identify with that. Sometimes folks outside of academia don't really understand the science process, and that you all fail and hit dead ends often, just as often as everybody else. It's not just like every experiment or every data run works out perfectly the first time. You've got to go back and change things. So talk about that process, make it more human. Talk about the actions you're taking, the emotions that you're feeling, or things that are going on. If you're talking about, you know, a natural disaster happening, you're talking about wildfires, you know, those are very emotional things because they can affect our lives and our property and our well-being. So think about those things and definitely incorporate them. Emotions are really powerful. This photo on the right here, this is Dawn Dawn Williams, and she is a scientist at Esri. She really loves Legos, and so she's always posting about herself building Lego sets and things. And so that's just the kind of thing that you could think about incorporating. You know, is there anything about you that you really love or that you just want to, you know, share with others? There we go. One thing that will really help you in writing is telling a story and just learning how to incorporate the narrative arc and narrative themes into what you're doing. So here's just like a quick little diagram of the simplest kind of story arc that there is. And because you guys are scientists, I know you love charts and graphs, so I've put this in the form of a graph. You can really think about it as tension or suspense over time. So most basic element of a story or structure of a story is you have your exposition. That's where you set the scene. You have something that sets off the plot or the storyline. That's called the inciting incident. It's the first conflict point or the first big point in the plot. Then you have your rising action. So the tension in it or the suspense is now building. You've got conflict, you've got obstacles. Somebody's trying to do something, figure something out until finally hit the climax where you've, you know, slayed your dragon, you've overcome all of your obstacles, and now you're on the downswing. It's really the turning point. Then you have your falling action. This is everything that ends to the resolution of the plot. I always like to use a Lord of the Rings analogy. You know, you think about it, you're Frodo, you're going to Mordor to get rid of the ring. Here, the climax is when he throws the ring into the fires of Mount Doom, but it's not over. They still have to return to the Shire. You know, everything has to close up. So then you finally resolve your conflict, and then what's called the denouement, just tying up all the loose ends. And you can see that the very end, this isn't go back to the very beginning level of where it was. It's a little bit different. You're not really coming first full circle because the characters have grown, the characters have learned something. They're in a different place now than they were before. So this is just kind of something to keep in mind. You don't have to, if you were trying to tell a story, you don't have to follow this exactly. And many stories have multiple climaxes and multiple plot lines that kind of follow this. So just think about it. Just think about any way that you can create tension or suspense and then resolve that tension through your findings or through your work. And so there are actually a lot of narrative themes that appear in literature that are really applicable to science. So I'm going to just go over a couple of them for you guys to keep in mind. This might really help you kind of focus your storytelling or your writing, and just kind of putting it into one of these contexts might help you really pull out the story well. So this is not an exhaustive list at all. I'm sure there are others. These are just the ones that I find pop up in science most frequently. First is the journey. It's pretty self-explanatory. Someone's going on a journey, accomplish something, find something, whatever it is. A really good example of this is the documentary Chasing Ice, documenting a National Geographic photographer's efforts to photograph time-lapse images of glaciers to show climate change. So the story, it's a really great film for anyone who hasn't seen it. It's about climate change, but it's also really about the people involved, and about James Balog, the photographer, and his personal journey to capture these amazing images. So highly recommend that if no one has seen it. The mystery also, this is classic science. You know, there's some unknown that we're trying to figure out. A really great example of this is the Ghost Map. It's a book written by Stephen Johnson. It's about a cholera epidemic in London in the 1800s. And from this epidemic, people who were not even scientists figured out that cholera was waterborne, whereas before they thought it was airborne. And so it was through this one epidemic, they had solved that mystery of where cholera came from. Really helped them in the long run. Along Came a Stranger. This is kind of the classic Western where like someone walks into a bar or walks into a town and nothing is ever the same again. But it doesn't have to be about a person. It could actually be about an event, like maybe a disaster. A really great example of this is this documentary Trouble the Water, which is about Hurricane Katrina. Think about a storm rolling in and just changing everything about people's lives from that point forward, and then how they move on and how they go forward from that. Coming of age is also a really common theme, and this is very simple. It could be, you know, someone coming into their own as they grow as a person. It could also refer to a field itself, coming of age. So one example of that is The Poisoner's Handbook by Deborah Bloom. This is a book that talks about a series of people in New York City during the Jazz Age trying to solve lots of poisoning murders that were popping up. And so they basically had to invent the field of forensic science to figure out how these people had died through various things. So it was a really great story about how this entire field of forensic science came about. Perseverance, I'm sure you guys are all familiar with that. So just staying the course, really trying to get something done in the face of all the obstacles. Hidden Figures is a great example of that fabulous story. And justice, which I'm sure you guys are also familiar with as well. Whether it be environmental justice or any other kind, justice always tends to crop up in science work, especially with disasters, with pollution, environmental issues. So think about any of these, how maybe you could incorporate them into your writing, how your science maybe fits into one of these. But like I said, these aren't the only ones, there are others. But they're here, these are just here tools to help you. So now that we've talked a little bit about storytelling, I'm gonna make you guys do a little activity, and don't worry, it's easy and it's fun. I am gonna show you 3 photos, and I want you all to make up a story about these photos. You can take one of these photos and just make a story about one of them. You could take all 3 and put them together into one story. You could take 2 out of the 3, whatever you guys want. I'll give you a few minutes. Just look at these images and make up anything you want about what is going on in any of them. And for you folks online, think about that too, and you can throw them in the chat if you like. I'll give you guys a minute.
Does group work or independent?
Independent. Well, it could be both. It could be both.
Okay.
If you guys want to do it together. Yeah. Or you guys can we can just shout them out too. We don't have to really like think about it. I mean, yeah. Anyone brave enough to share?
All right, we'll show the one that Kai and I just came up with.
Sure.
Okay, we chose number 1, and Kai pointed out that it looks like she has 2 radios maybe. So we're thinking there's been some kind of miscommunication, and there's like, I don't know, maybe 2 teams on opposite sides of wherever they are, and she's the middleman, trying to be like, wait, where are you? What? Oh, okay, they're over here. Wait, what? You know, kind of going back and forth between the 2 teams.
I love that. Anyone else brave enough? Yeah.
One for number 1, which is that the people who were in charge of the radio just handed them to her and then
I love that. And now she doesn't know what to do with them.
Is obviously the great lost the office bet.
How does the banana figure into it though?
I think the banana's into it. It's the banana's regular day.
Oh, okay.
That's why the great is out there interviewing.
Mm-hmm. Anyone else want to share anything? This is actually me. So this was, go ahead. So these 2 photos are at McMurdo Station in Antarctica. This is a woman named Gina. I don't even know what these instruments are. She's measuring something here and she's just really confused about what she's supposed to do. This is me coming out of the observation tube. It's like a tube that goes down below the sea ice, so you can watch seals and other animals swimming around, and it's really tight and narrow, and it's just me popping up, being very excited. And then the grapes and reporter is actually a cute story, or the grapes and the banana. So this banana guy, he was a student who was autistic, and he got in trouble for wearing this banana costume to school. So the local media heard about it, and they decided to interview him, and the reporter dressed up in a grape costume for solidarity to support him. So yeah, very cute. But awesome. Anyway, the point of that is just, you know, you can make up a story about anything. We all have different perspectives on what we think is going on. So just use that to your advantage. Awesome. And so something that can really help you guys is to incorporate elements of news writing when you're writing a blog or anything else that's aimed at, you know, not academia. So news writing, and I bring this up because first to show you guys what the difference is between news writing and academic writing is, it's a little bit different. So normally if you're writing a paper, an abstract, presenting at a conference, you start and you kind of go chronologically. You start with your intro, the background, the previous research, what is already known about this area of research, this topic. Then you get into the methods of what you did in your study. And then finally you get to the results, the discussion, the conclusion. News writing is the complete opposite, and we call this the inverted triangle or inverted pyramid, even though it's really just a triangle. News writing starts with the outcome first. So what's called the lead is the results and the implications. It's basically in science news writing, it would be, what did you find and why do we care? Then it goes into the body, which is the who, what, when, why, where, which is a little bit about everything here on the academic side. A little bit intro, a little bit of background, a little bit of methods. And then you kind of go into the results again, how the scientists got those results. And then the tail or the end of the story is just any extra details, what's next, kind of just rounding it out, making sure it ends on a nice, it's all tied up at the end. So there's a couple of reasons that news stories are written this way. The old school reason is that back in the days of print news, if a story was too long and it wouldn't fit on a page, the editor would just take out a pair of scissors and cut off the bottom of the story to make it fit. And if you put the results, the discussion, and the conclusion at the end, then you lose that, which is the most important point, which is what you found. So they flipped that on its head. The other reason is that people have short attention spans nowadays, and they really got to get to the point quickly. So the point of the news story is really to give people, let them know what the outcome is at the very beginning. Like, don't keep them in suspense. This is like the opposite of storytelling now. It's a different kind. You know, you're not keeping anyone in suspense. You're telling them right away why they should care about what's going on. So what things that you all can do to think about how to maybe incorporate elements of news writing is really just to zoom out, focus on the big picture. Think about how this work fits into the larger picture of science and society. Draw in your audience with a good headline, a good lead, visuals too. You know, you want to make sure you're clear and concise, again, especially in the headline and your first few sentences, first paragraph. If you have interesting visuals, absolutely include them and get them high up in your story. Before you start writing, distill out your key points, like maybe two or three things that you want the audience to take away. If they remember nothing else about your blog or your story, what are the few things that you want them to remember about this? And again, focus on the outcome. If you have results, focus on those and their implications. Or if you don't have results, maybe you're just talking about a new project that's just starting yet, or anything that doesn't have a hard result yet, just think about what the results would mean, or how this project impacts people, impacts society. You really just wanna, it's really a distillation more than anything else. You don't wanna, it's not an information dump. You don't wanna overload them with facts and too much info. Really just focus on the things that are the most important to the story. And like I've been saying, incorporate multimedia, photos, videos, drawings, animations, even GIFs and memes, whatever you want to include in there that will help tell the story of the research. This is a photo from CIRES Rendezvous last year. This grad student, she made this whole illustration showing her work studying the influence of iodine on ozone destruction. Really cool. She drew all this herself. And if you don't think that you're artistically talented, that's okay. It doesn't have to be sophisticated. First of all, there's many tools at your disposal, which some of them I'll show you. Or you can you really don't have to make it super sophisticated. Even simple drawings or illustrations are really helpful. These are just two drawings from this blog that I really love called Hyperbole and a Half. I don't think it's going on anymore. I think the woman stopped writing it, but she just basically made a bunch of drawings in Microsoft Paint, I'm assuming, to illustrate her blogs. And are they sophisticated? No, but they're cute and they're funny and they help tell the story. So you don't have to be really artistic. I can't draw for anything, but I can design things on a computer pretty well. So just think about those kinds of things. Well, that's not going to show up, but that's okay. Here's a couple infographic examples. Think about how you could maybe display your data in a more graphically or visually appealing way. These are two infographics that I came up with a couple years ago. First, showing iron concentrations in animal milk. I was writing a story about seals and how much iron they have in their milk that they pass along to their pups. They have way more than humans do, you can see, like by orders of magnitude. So it's really interesting. And then this other graphic here, just showing there were 4 different types. Researchers found there are 4 different types of whale calls made by this one type of whale. And so this just shows kind of the context for each call, like which ones are made during the day, which ones are made at night, which ones are made when they're in groups or when they're alone or when there's food around or when there's not food around. So you could think about something like that. And a lot of these elements here, these are like stock graphics that I found online and then incorporated them into my infographic. So there are tons of tools and resources out there that you can use. You don't have to design everything from scratch if this is what you're interested in doing. Like there's no way I could have like come up with these animals here, done that. No, those are all stock animals. So lots of tools out there for you guys available to you. And make it meaningful. Like I said, the two most important things that you should incorporate in your work are, what did you find if you found something, and why people should care. If they don't know why they should care, they're not going to read the rest of the story. So really emphasize the value of your work and show how your science is relevant to people's lives. There are lots of things that we already care about as human beings living right now. So, we care about our well-being. We care about having clean air and clean water. We care about our future. We care about our identity, whether it's our community, whether it's our country. We care about all these types of things. So think about ways that your science connects to those things. And to you all, like, the connection might be obvious, but to someone who's not in academia, they might not understand that. You really kind of have to hammer it home and make it obvious. And whenever you can, I always say, try to end on a positive note, or show that we have an opportunity, or that science is part of a solution. A lot of times with climate science, especially, or environmental science, it can be very doom and gloom. And that is really hard for people to reckon with sometimes. If they think that it is hopeless, people will tend to shut down, and they're not going to engage with it. They're not going to even try to make a difference, to make things better. So whenever you can, try to show that that there's positive aspects to whatever you're talking about, that there's solutions, that there's opportunities to, let's say, safeguard our water resources or our air quality, things like that. So try to help people engage in that way. And the last one is just have fun. Don't be afraid to just be silly, be creative, just have a good time. I hope it should be an enjoyable experience. And, don't take it too seriously. Don't take yourselves too seriously. Just have a good time. And that will really come through in your writing or your communications work, whatever you're doing. Just enjoy yourself, and it will really help people engage with you and what you're saying. And I think that's everything I wanted to go over. I have a couple of resources here for you guys. If you're interested in using social math and you're not sure where to start, there's this great tool called the Measure of Things. And so you just go online, and I will share all these slides with you guys so you can get the links to them. It basically, you just put in an amount like 10 kilometers squared, and it will give you a whole bunch of comparisons to choose from. Like, let's say it's like twice the size of Central Park, or half as tall as the Empire State Building, things like that. So it will automatically come up with those things for you. It's a great place to start. Canva is a free, easy graphic design tool. We use it at Serious Comms. There's tons of stock graphics, stock like elements, and whole infographics. Like these are just stock infographics that exist on the site that you can modify, you can build off of. If you want to use one of these, that's great. Or you could just use it for inspiration if you're not really sure where to start. Headliner is a free video editing software that's online. It's super easy to use if you're a little bit intimidated by video editing, because a lot of the software, especially for pros, is really hard to get started with. But Headliner is a great place to start if you're interested in that. You can even just take an audio file, put it over some images or some video, or make a whole video from scratch. So I definitely recommend checking it out. AGU's Sharing Science program has tons more resources too. I helped create a lot of them, so I always give it a plug. They have more resources for, honing your science message, things like common jargon that scientists use and other words to replace those words with, or other phrases that will help, things like that. Definitely check them out. They've got tons of stuff. If you're curious about what the reading level is of what you're writing, you can check it with this Flesh Reading Ease tool. It'll tell you what the reading level is, what the grade level is, how easy it is to read. And actually, I don't think Google Docs has it yet, but Microsoft Word has a tool also that's built into the spelling and grammar check that lets you check the reading ease too, just like the reading level. And then here's a couple links to some blogs I found that I think are really great. There's a Real Climate blog written by scientists about climate, obviously, really great. This blog by the SPIDER team. So SPIDER was a project from a couple years ago. It's not really an acronym. It's just called SPIDER. But it was a telescope that they attached to a high altitude balloon that went up into the stratosphere to study the early universe. And the team deployed this from Antarctica. And so they have a really great blog about how they built the instrument, how they built the telescopes, how they got it down there, how they tested it. and then they launched it and then what they found. So really, they did a really great job. And then CIRES has blogs too that you can check out if you just need some inspiration. And that's it. Any questions or anything you guys want to talk about? Yeah,
Great.
sure.
I have a question.
There is a trope about the interaction between scientists and communication departments. And it generally goes something like the scientist says, it depends. And the communication department says, why does it matter? And they go back and forth. But I think the tension that reveals is that from the scientific point of view, it often is like, okay, we have developed some theory that tells us something better about how this works.
Mm-hmm.
And that's a nuanced understanding about if it's doing this way, if something's acting this way, it does this, if something that way. And then the comms person will say, well, why does it matter? And eventually it's like, oh, we're saving climate change. And it's sort of like oversimplified and the target is moved in order to say a simple message to a general audience.
Mm-hmm.
And so do you have any notes on sort of, yeah, how do we actually tell complicated messages to the public without just feeding them something that is close to the approximation of what we're doing?
Mm-hmm. Sometimes it has to be an approximation, like you're saying. Like sometimes there is no simple way, easy way to do it. And I think, yeah, it's hardest on you guys to reckon with that because accuracy and precision are, you know, your bread and butter. Just keep workshopping it and, you know, try to find that sweet spot between not oversimplifying it too much and actually making it too complicated to understand. Yeah, it's hard. I mean, if you had an example, we could talk about it more, but it's hard. And sometimes sometimes with those like simple messages to you seem really simple, but to someone else outside of science, like it makes sense to them and it is meaningful to them. So just keep that in mind too.
Yeah, I think the best example is that a lot of our work here just gets clumped into the, like, we're solving climate change.
Mhm.
And if there's no solving or,
Mm-hmm.
you know, even if it's not even that climate change related,
Yeah.
that's sort of the bucket that gets dumped into.
That's okay though. It could just be like, you're contributing to climate change solutions. And like, because even though it seems like a big grand statement, like it's true. But you could get a little bit more granular with that. Like, I'm trying to think. I don't know. We could talk about it more, but yeah. Mm-hmm. It's really hard though to just let go of that level of accuracy, I guess, or not accuracy. Yeah, precision. Mm-hmm. Yeah.
I'm curious with the series communication, like who your audience is. I often wonder who reads these. There's stories about, it's like,
Yeah.
do we actually think it's like people, or like, is it me? I'm reading like a story about physics.
Yeah.
It's all very educated, science interested people anyways.
Yeah. We have multiple audiences that we try to reach, which makes it even harder. So the goal, I think, for us is that any human adult with an interest in science could read it, would or could read it and understand what's going on. But within that, it could be specifically we're trying to hit journalists. Even though they're not directly an audience, policymakers. The goal is that even if we're not targeting these people, we want anyone to be able to come and read one of our stories and understand it. But most of our audience is scientists or science interested people or people adjacent to science, advocates or policy people who work on policy, things like that. So it's tough. Yeah, it's different audiences and we try to hit as many as we can, but it's challenging for sure. Mm-hmm. Yeah. Yeah.
You say, so, journalists or news people as one of your maybe target audience for that. What's the best mechanism to feed science results into the news cycle?
Yeah, come to us. Come to us. Yes, come to us. Yes. If you have results or if you're not sure, or you just want to talk about it in general, like what journalists are interested, come talk to us. So yeah, what we can do is we can write a story about your work, and then so when we write a story, we may send it out as a press release specifically to journalists. We may promote it on social media and tag certain journalists or point them to it. So we want them to be able to, we want them to see CIRES as a source of high quality earth science news and environmental science. So yeah, come talk to us at any point. Reach out to us and say either if you've got results, or maybe you don't have results, but you're working on a cool project that people might want to know about. And the best thing is come to us if you can before your paper's published. That gives us time to prepare something, because usually when a paper is published, journalists want to cover it if it's newsy right away, usually like within a week. So if you tell us after it's already been up, then after it may get old, may become old news before we get a chance to get to it. So try to tell us as soon as you can, and we'll figure out the best way. We may even do some targeted outreach to reporters. And the other thing you all can do, I mean, if you have been interviewed by reporters before and you're interested, you can build a relationship with them. They are always looking for experts on topics. For example, like with this wildfire smoke that is just making our skies all hazy today, people might be coming up being like, why is the haze so bad today? Where is the smoke coming from? What are the impacts on our air quality? What are we breathing? So they may reach out to us and say, hey, we want to talk to somebody about that. And so if you all are interested in that, you can do that. You can come talk to us about being an on-call expert. They may ask you to comment on another piece of research that you're not involved in as an outside expert. You can also, if you want to build relationships with journalists, again, come talk to us first. We'll help you all out because our job is to maintain relationships with them. But you could have them come on a tour of your facility, lab, whatever it is, build a relationship with them, tell them about some interesting stuff that's coming up. They always love seeing science firsthand. So that's one thing you can do. Yeah.
Thanks for
Yeah.
sharing that. That's great.
Yes.
All right, that's
We are here to serve you. Yeah. I know some people aren't sure what we do. We are here to serve you all and to highlight and get your awesome work and get it out there to whoever is interested in it. So, and to get it in the right hands of people making decisions. So, to make sure they have the most, as much information as they can. So that's what we're here for. Anything else? I will send Allison and Casey these slides to share them with you guys. So you don't have to worry about remembering everything that I said, but and you have the links that I put in there. But you can always reach out to me or to any of my colleagues. I thought one of them was going to be here today, but she's not. But always reach out to us. We have offices on main campus and at NOAA. So we're here to help.
Thanks, Lauren.
Yeah.